Okay, so the quadratics test review, you're looking to test on Monday. A few things we need to recall about a quadratic function. That parent function for all of these graphs is simply y equals x squared. And that creates our parent function, a parabola, with its vertex at 0, 0. So a couple things we need to identify about the graph of a quadratic function is this right here, this dashed line. It's a vertical line right through its vertex, right through the middle, is called the line or the axis of symmetry. So if I took this left half of the parabola and folded it along this line, it would lay right across onto the right side. This is a line of reflection. Secondly, these 2 points right here, where this graph intercepts the x-axis or touches x, are called roots, or simply x-intercepts. And then this final point down here, right where I'm going down, 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 I hit the lowest point and then head back and change directions. That's called the vertex. So just a little reminders on some different parts of our quadratic functions. Let's take a look at some examples. So identifying these given a graph, again, I'm first asked to look for the coordinate of the vertex, and I see the vertex is right here. It's where my graph begins to change direction, and that is at the coordinate 1, 5. And then is it a minimum or maximum? I see that this is actually the peak. It's like standing on top of the mountain. It's the highest point on the graph. So that's a maximum. There's no values of my function above that point. And then the equation for the axis of symmetry, that vertical line right through the vertex, actually has a relationship with that vertex. It is x equals and then 1. It goes through the vertex, so it's that same x value of 1. The domain. Remember, the domain is all possible x values. What values can you input into the function? And then the range are the y values. What values come out of it? So if I look at the domain here for this given parabola, I know that this continues indefinitely, and I know that from the arrows, and it's going to continue to widen ever so slightly forever. So it's actually going to be x values. So it's all real numbers. And then the y values are the values of y that are, since I have a maximum here, I see my graph's actually going downward, so that's less than or equal to. And what's the highest value, that maximum, the greatest value of y that you can have? And it's going to be 5. So I see that that also corresponds to the y value of my vertex. So a relationship there between the vertex and the range of the function. Let's look at the next one down below. Again, I'm asked to identify the vertex. That's this point right here, which is at negative 5, 2. And in this case, that is a minimum point. It's the lowest point on my graph. It's in a valley. There's nothing on my function below that. The line of symmetry, remember, corresponds to that x value of the vertex. It only touches x, so the equation's x equals, and it equals negative 5. That same x value of the vertex. The domain, again, is all real numbers. It's that r with the extra backbone. I drew that one a little far away. There we go. And then the range, in this case, I have a minimum, so all my range values are actually increasing, going upward, so it's greater than or equal to, and then it's the y value of that vertex, the lowest point on my graph, which is at 2. And let's look at a couple different examples. In these ones, I'm actually asked to graph the function. So I have 3x squared minus 5. So when I substitute values in here, and I can certainly do this on my calculator to aid me, turn it on, we'll go to y equals. If you ever have any problems or other inputs in here, just go ahead and clear them out, and you can do that by hitting second plus 7, 1, 2. That'll clear all the short-term memory on it. And we'll go to y equals, and we'll graph 3x squared minus 5. So that's what my graph should look like. I see it looks like it's slid down. And I go to my table to plot these values. And I have 0 in the center, so I'll center it up. And I see that value is negative 5, and then it goes to a negative 2 on either side of that, and 7 on either side of that. So negative 5, negative 2, 7, negative 2, 7. And then I can plot these. So I go to 0, 1, 2, 3, 4, 5, over to 1, and I go down to 1, 2, and then over to 2, and now I'm way up at 7. So 2, 4, 6, 7. And now, since I know that this is the line of reflection here, the y-axis, I'm just going to reflect these points over, and it makes them very easy to plot. So my graph looks something like that. And I can do the same thing with the second function. I'll go back to my y equals. I'll hit the clear key. I'm going to put this in as a stacked fraction, so I'm just going to go ahead and put a minus. Then I hit alpha y equals, enter. That'll give me the stacked fraction. 1 up top, 4 in the bottom. I plug in x squared. And I see this one's actually reflected, and I knew it would be from that minus symbol there. And it looks like it's opened wider. And I know that when this value is closer to 0, that this gets more bowl-shaped, it gets wider. So again, I'll just go to second graph, takes me to the table, and now I'm graphing 0, which is at 0, 2, which is at negative 1, and then I need to go to 4, which is at negative 4. So we'll plot those. And it looks like this one got cut off here. We'll just plug it in. So this one is actually at the origin. I go over 1, 2, and then down 1, then go over to 4, and down to negative 4. And again, this y-axis is the line of reflection, so I just reflect these back over. And this one opens up like that. Simple as that, very easy when I use my calculator. Okay, so we'll take a look at the next example here. When we're identifying the changes, well, we know a couple things about these parabolas. We've talked about a few things. What I can remember, sorry, let me put up a dark box here. There we go. What I can remember about these is I have that general form y equals a times x squared plus c. Now there's a bx in here, but for our purposes in Algebra 1, we essentially just omit that. So a, this value, makes the graph wider or narrower. And we simply call it fat or skinny. And remember, the bigger the number, the further from 0, the skinnier the graph gets because it grows quicker. And then the further away from 0, or excuse me, the closer to 0 rather, then the wider it gets because it grows slower. And then C is what just slides or translates the graph up or down. So with that in mind, these are pretty easy to do, and they can be pretty quick, because I know that if I have 1/4 x squared, that's closer to 0. These are all comparing them to the parent function here, which is that y equals x squared. So how do they relate to this? And I know that if this is 1/4 of the x squared, this one actually gets wider. So that would be D. Certainly I can graph any of these in my calculator and compare them to the original to C. So there's no reason to miss any of these. When I look at 17, I see a negative symbol here, so I know that's actually going to reflect it. That reflects it and opens it down. So that one would be letter B, opens downward. And then I see it also has a +3, so that +3 is actually sliding it up. That's a translation, translating it up 3 units. And I'll show you what I'm talking about on a calculator to graph that. If I'm unsure, I just put in the parent function here, x squared, and I'm going to plug in this equation, negative x squared plus 3. And it will first graph my parent function, there's the original, And now here's the new one. And I see it's actually reflected, and it slid up 3 units. This one again, because of that right there, I know it opens downwards. And because of this guy here, the times 8, he's actually going to be skinnier. And on 19 here, the 3 is going to make him skinnier, narrower. And then the plus 19 actually slides him upwards, which is E. Now, a different way to kind of ask the same thing, which parabola will open upward, so it opens up, and be narrower, so it needs a number further away from 0 than x squared, which would be a 1x squared. So if I start looking through the lists here, it opens upwards. That's a negative, so that one opens down. I know that for sure. I see in letter C, that one opens down as well, so that can't be it. This one has an A value of 1/4, which is closer to 0 than 1, so that's actually going to get wider, so that can't be it. So I see that A is the correct choice. It has a value of 6, which is further from 0, and it opens upwards. Looking at 21, again, any of these could just be graphed. I could graph every one of these and compare them to the parent function of y equals x squared to see which one does what I need it to do. So 21 says, which of the following equations describes the quadratic parent function after it has been flipped upside down, and to flip it I know I need a negative, and shifted 2 units up. So it doesn't do anything to make it wider or narrower, so it should be an x squared, and then it moves 2 units up. So to move 2 up, I just add 2 to it, and I see that right there is letter D. Looking at 22, which of these would make this wider? Well, I know that wider is when I get closer to 0, so that again is D. 23, which of them would open downward and be narrower than the parent function? Well, downward I know needs a negative value. Negative, negative, negative. Can't be D. And it needs to be narrower, so it needs a value greater than 1, further away, which I see right here. So the correct solution is B. Then we get into some story problems, which aren't that difficult. I have an equation that describes the path of a rocket shot into the air. Let's just graph this in our calculator. We'll make it real easy. Go to y equals. I'm going to clear these out. I'm going to put this in negative 16. My calculator doesn't have the variable t, so I just use x squared plus 52x. And we'll go ahead and zoom, and we're going to hit zoom 9 to fit this graph. And I see it opens downwards. This is not a great picture of it. Let's see, let's zoom in a little bit. That might have been a little too far. So whenever you have problems with your graph, just hit zoom 6. It'll take you back to the standard window. This is fine. I see it looks like it actually intercepts probably about the origin here and somewhere about 1, 2, 3. And then it must have a maximum somewhere way up here. But what I'm ultimately asked is, what is the height in feet after t seconds? So I want this function evaluated when t is 2. So I can go to my table for that purpose, and I see when I plug in 2 for t, for the time, my rocket is at the output 40 feet. And we'll scroll down and finish up the last one here. And a cannonball is fired upward. The equation describes the path is height equals 100t minus 16t squared, where h is the height in feet above the ground after t seconds. What's the height after 5? Again, this is asking the exact same thing as the prior problem. I'm just going to go to y equals here, and I'm going to graph this function. That's 100x. Let me just clear it out and start over. 100x minus 16x squared. And again, we'll graph that. It's not going to look real good because the dimensions here are -10 to 10. I do see part of it there. Really, what's most useful for me is the table. I'm evaluating it when it's at 5 seconds. So I go to 5, and I see that that is at 100 feet. So the correct solution there is A. I could also just sub in that value, 5, so I can put H equals 100 times 5 minus 16 times 5 squared. And I can plug this into my calculator to evaluate it, and you'll see you get 100 as well. So that does it for the review. You need to be prepared for an assessment for a test on Monday. I'll take any final questions over this prior to that, and then we'll start it. Have a great weekend.